Dale Leavitt's back, this time developing a research program to address shellfish growers' needs. Ninigret Pond, a case study.
I made those letters nice and big so you can read
Well,
them.
I appreciate that. A guy my age needs that. It's a very pretty place. Thanks, Dale.
Okey-doke. So, in recent years, there's been a real explosion of oyster aquaculture in some of our coastal ponds in the area of Rhode Island that we refer to as the South County, which is sort of from Narragansett Bay south along the coast to the Connecticut border. And one of those ponds is Ninigret Pond, and it's just a typical shallow water coastal pond, bounded on the seaside by a barrier beach. And in this case, it has one very small opening, which is the sole source of flushing and the exchange of seawater in and out of the pond. And so the oyster growers there, because it's a shallow water site, have been using these low profile bottom cages where the oysters are put in these mesh polyethylene bags, and then the bags are put in basically these wire cages that have multiple shelves on them to hold numerous bags. And since we've started developing oyster farms in the pond, which started in about 1999, the farmers there have noted that as the number of farms increased and the size of the farms increased, that they're starting to see first a huge increase in numbers. As you can see from this very simple little graph, the number of oysters coming out of the pond doubled in a matter of 2 years, from 1 million to 2 million oysters. And concomitant with that increase has been a real, what they described as a very dramatic decline, both in growth rates and an increase in mortality on their farm sites. And so a couple of years ago, 6 of those farms, Bean Family, Walrus and Carpenter, East Beach Blondes, which is 2 different companies, 401, and Ninigret, got together with an academic researcher who shall remain nameless for reasons to be discussed in a minute. They submitted a proposal to a local state funding program called the Local Agricultural and Seafood Act Grants Program to try to investigate what some of the mechanisms might be behind their perception of decreased growth rate and increased mortality. And so the question was, has the increase in oyster plantings exceeded the carrying capacity of the pond? And just as a side note, there actually was a study that was done a couple of years ago with one of our other coastal ponds that seemed to suggest that we were nowhere near approaching carrying capacity in any of our ponds, and we could have something like 400% increases in oyster production just based on all of those nice nitrogen contributions coming from our upland landowners. And so the researcher who was going to generate a graduate student was going to study seasonal and tidal variation in food levels across the pond, measuring chlorophyll and particulate organic matter. And then the farmers, in coordination with the researcher, were going to do some survival and condition index or meat weight to shell size studies on oysters that were cultivated at varying densities within their culture gear. And they got the award. However, as they were getting ready to gear up to do that, the shellfish biologist, the academic, was supposed to provide the grad student, said, "Oh, by the way, I'm going to be gone all summer, so I can't help you." And so what that resulted in was me getting a panicked phone call one day saying, "Dale, we've got this money, we've got the farms, we've got everybody organized, we have no idea what to do, and we don't have anybody to do it." And so that was about 2 weeks before we really should have started on the experiment. So now what do we do? Well, after I got on the phone and pulled people together and had a couple of meetings and talked with a bunch of folks, and after we get done cursing the original academic for pulling out on us, we put together a study plan that I thought was fairly reasonable, something that we could do. We had to some of us had to clear our work schedule to allow the study to take place. We pulled together a team to conduct the study, and then we went forth and very quickly validated a few protocols and compiled the equipment that we needed to get the study done. And so our objectives were to measure the seasonal variation in food levels along transects that were cut through that bank of existing farms along the barrier beach. We're going to measure oyster survival and growth at various stocking densities within the 6 farms that were participating. And then we're going to evaluate the condition index of oysters that were grown under those varying density, in varying densities in the bags. So to meet objective 1, we would go out there on 3 different occasions, and we threw this little drifter into the bag, or into the pond, and we knew enough about the hydrodynamics of the system so that we could position the start of the drifter track, so that the tidal currents, what small currents there were in there, would actually drive that drifter down through the array of farms. The assumption being that as the drifter moved, we were basically going to be resampling that same central body of water as it moved through the farm. And so we followed the drifter, and every half hour we took a set of measurements of chlorophyll, particulate organic matter, salinity, temperature, depth profile, Secchi depth profile, and we did a whole workup of water quality at the location of the drifter. And so we did that on 3 different occasions. I don't expect you to look at all these numbers. I just wanted to prove that we did in fact generate some data. But we did it on 3 different occasions that sort of corresponded to 3 sort of key points in the seasonal growth cycle of the oyster. And as you can see, this is just looking at particulate organic matter, which is a proxy for the amount of food in the water. The transects that we did in July and October, we didn't see any change in the actual food density as you moved, and you can see these transects as they moved down through the oyster farms. The only time we did see a decrease in actual food availability as we moved through the array of oyster farms was in August. But if you look at the levels that were actually we were observing, those August samples at their lowest point were higher than the highest samples of the other 2 occasions. So we really were not able to demonstrate that there was any kind of food limitation in terms of the overall water mass as it moved through the arrays of farms along that barrier beach. The next thing we needed to do was look at oyster survival and actually document that what their growth rates were. So we had the farmers contribute to stock 2 oyster bags at their regular stocking volume, and then another 2 bags at a half and another 2 bags at twice their normal stocking volume. Put those in a cage, set up 2 cages with the same configuration on 2 locations on their farm. And then after a month, they pulled the bags in, measured the total volume of oysters, which is a proxy of individual oyster growth, and then they pulled out some samples for us. And so we got 2 of these growth sequences in the course of the summer. And as you can see from this plot, this table, we didn't see any kind of mortality to speak of. We were routinely around 97% survival, which actually is fairly good for an oyster farm. And if you looked at the impact of stocking density on growth rate, here you can see that there is definitely a relationship between the amount of oysters that were in an individual bag and the actual growth rate, where if you stocked at 1 liter of oysters per bag, you got maximum growth, and if you were stocking at anything over 8 to 10 liters per bag, then you got really minimum growth. And there was a very, very obvious relationship there between stocking density and actual growth rate within the bag. And then the last thing we did was actually look at condition index, where we measured shell morphology as well as soft tissue dry weight. And then if you looked at the condition index change over the growth period that the growth study was done, we see that in all cases but 1 farm, we saw a decrease or drop in condition index, but I'm not sure that that's really significant because that's probably something to do with the regular seasonal cycling of the condition of those organisms. And if we try to look at it in terms of stocking density, there really wasn't any relationship in terms of condition index versus actual stocking density. And so basically what we were able to tell the growers is that we thought that the food resources in the pond were consistently adequate. However, there was a localized effect of growth depression inside the bags as the stocking density increased. And that growth depression was probably the result of sort of the microhabitat within the bag, because our flow rates, we have that 1 outlet, so the tidal exchange in that pond is negligible, and the tidal currents are extremely slow, 0.06 10 meters per second, which, 0.1 meters per second, which is not a particularly fast rate. So we don't think it's allowing enough food to flux into those bags and actually provide the oysters with enough food, even though there's plenty of food all the way around them. And so basically what had happened is, as these guys were increasing their farm production, in order to save money costs on bags and the costs on labor, they were starting to more and more heavily stock their bags to accommodate this increase in production that they were trying to target. And so basically what we told them is, you guys are going to have to adjust your stocking density to accommodate this fact that you just don't have enough flow in your site to allow you to put 4, 8, 10 liters of oysters in a bag. And so basically, just a quick conclusion, these are sort of my evaluation of what as an extension agent you have to do in order to address these kinds of conditions. First, you need trust. It was really important that the farmers were aware that I was available and that I had the expertise that could assist them in carrying forth with this project. You got to have time. You have to have the flexibility to be able to rearrange your schedule so that you can adapt to these last-minute time requests for effort and expertise. You got to have support. You need the lab space. You need the equipment. And you need the availability of people to be able to carry forth with these kind of really quick response types of situations. And you need collaboration. You need to be able to work with farmers, even though they can be a real pain in the ass at times, because business comes before research. And so if they have time for carrying forth with the research, they'll help you out. But if they get jammed for time, they're going to take care of their business efforts first. And so with that, I'll finish up.